Hello, my dear students. Welcome back to the lecture. In this lecture, we will see how a beam is practically designed with the help of an Excel sheet. So I'll be taking to one of the Excel sheet and we'll see that. Okay. So this is Excel sheet what we have. So now why I'm trying to explain this is that we have seen in the structural drawing, right? They're given a 12 diameter 2 bar, then they're given a 16 diameter 3 bar, they're given a 16 diameter 3 bar, right? But from where do we design all these things? That is 16 number of 3 is going to come. Why it is not 4 in number? Why it is 2 in number? Why it is not 3 in number, right? All those things we'll try to see with the help of this Excel sheet. Now let us consider I'm taking a beam size. Okay. So you have to give an input here. Let us say the width of my beam is 230. I'm taking some random numbers. And let us say the depth of my beam is 450. Got it? So two input I have done, 230 and 450. So clear cover for the beam, usually we keep it as 25 mm. I'll keep it as 25 mm here. Got it? So again, what is the grade of your concrete? Let us say I'm making use of M25 grade of a concrete. And the steel, let us say we are going for Fe500, right? And then you have to input the moment here. This moment you are going to get from the E-tabs. But still, for our understanding, I'm taking a small moment. Let us say it's a 50 kilonewton per meter. Got it? The moment you do this input, okay, so you're going to get all the input here. See, now it's writing here, the beam is designed as a singly reinforced. That means you can see he's giving us, this Excel sheet is directly giving us what is the total steel that is required. So area of steel that is required is 304 square meter. Okay, mm square, 304 mm square of the steel is required. You're getting my point? I'll put it in a very better way. You don't have to worry. So first we'll try to understand what is this singly reinforced beam. See, let us say if this is my cross section of a beam, and in the cross section of a beam, we'll be having one layer which is called as neutral axis, right? In the initial classes, I had explained you something about the neutral axis, right? So I'll write here neutral axis. Yeah. So now let us say it's a simply supported beam. So where is the tension? This is my compression and this is my tension. So since my tension is below the neutral axis, in a singly reinforced section, what will singly reinforced beam, wherever we have a tension, no, there we are going to provide the reinforcement. So let us say I'm going to provide some reinforcement here. So I'll put one reinforcement here. This is my second reinforcement and this is my third reinforcement, let us say. So this is called as singly reinforced section. Why? Because here the reinforcement is provided only in the tension zone. This is called a singly reinforced section. Similarly, if I had provided the reinforcement, suppose if I had provided the reinforcement even in the compression zone, this is my compression zone. So if I provide a reinforcement even in the compression zone, then I call this as a doubly reinforced section. I call this as a doubly reinforced section. If it is provided only in the bottom, we call it as a singly reinforced section. I hope this much things are clear to you. Now you see here, right? The moment I put this 50 kilonewton load, what it is showing, the beam is designed as singly reinforced section. That means for this particular load and for this particular width, my beam is designed as a singly reinforced beam. So in this case, what will happen? I need to provide only the bottom steel. Now, how much area of steel you're getting? 304 mm square. Okay. So for that, I'm going to decide how many steel is required. In the layer 2, I don't require. I'll make it 0. Okay. See, I require 304 mm square. So if I provide a 25 diameter 2 bar, it is giving me area of 982 mm square. But my requirement is only 304, isn't it? So what I'm going to do, I'll reduce the diameter of a bar. Instead of 25 diameter of bar, I'll go with a 10 diameter bar. So if I go to the 10 diameter bar, and if I, yeah, so my steel requirement is 298 mm square. Okay. If I provide a 10 diameter 3 bar, I'm giving a steel of 236 mm square. So this 236, whatever I provided, is less than 298. So I'm getting a warning that provided steel is insufficient. So instead of 3, I'll increase the number to 4. The moment I increase, what has happened? 298 was my requirement, but I provided a 10 diameter 4 bar. So I'm getting 314 mm square and the provided steel is okay. That means in this particular beam of 230 by 450, having a 50 kilonewton moment, if I provide a 10 diameter 4 bar in the bottom, I can make this beam safer. You're getting my point? Now I'll try to see how many diameters of the bar you have to use. It is up to you. If you are a structural engineer, based on that, you have to decide it. Which one you have to take. Okay. Yeah. Now we'll try to do some other things in this. Okay. So now let us consider, I'll increase the moment. I'll say I will change this beam into a doubly reinforced beam. Instead of 50, I'll make this as 100. So still it is coming as a singly reinforced beam. I'll make this as 200. So now you can see here, see the beam is designed as a doubly reinforced beam. Why? Because up to, I'll go with 150 now. So now also it is coming as doubly reinforced. I'll go with 125. Yeah, so up to 125 it is a singly reinforced beam. The moment I increase the moment, what will happen? It will come if I put 150 kilonewton. If there is a beam of 230 by 450, and if I'm putting a 150 kilonewton load, then my beam is designed as a doubly reinforced beam. So in this case, you can see I'm getting a steel area of steel, that is percentage. In tension, I'm getting 1.0474 percentage, and compression steel also I'm getting. So I'm getting a area of steel even in the tension zone and also in the compression zone. That means if it is, as I mentioned, if it is a doubly reinforced beam, then what will happen? You are going to provide the steel even in the bottom also. Of course, that is your tension region. Along with that, even in the compression region also, you are going to provide the steel. So that is the importance of a doubly reinforced beam, right? Now, for the same beam, we'll try to do that. See, first we'll go with the tension zone. You just concentrate on the tension. Okay, you can see here, tension reinforcement I'll provide here. And this is my compression reinforcement. So compression steel is 134 mm square and tension steel is 1018. So what we are going to do, we'll start with the 12 diameter bar. I'll provide a 12 diameter 4 bar. I'm getting an area of 452 mm square, but I require 1020. So it is the provided steel is insufficient. Now you can make a combination. Instead of 12 diameter 4 bar, I can increase this number to 8 also. Okay, but practically providing a 12 diameter 8 bar in a single layer is not possible. What is this layer all about? You can see a layer 1, layer 2, and layer 3. So if I draw a cross section of that, see, this is my layer 1, let us say. Okay, this is my layer 1. Oh, okay, and over that, if I provide another beam, over that, if I provide, this is my second layer. If I provide, this is my second layer. Okay, now what we have done here, see, we have provided 12 diameter 8 number of bar. So practically, is it possible to provide a 8 diameter, 12 diameter bar 8 numbers in one layer? It is not practically possible. So you can go with the 2 layers, right? So what we can do, I'll put it in a better way. See, instead of this, I'll make it as 10. Now you see my requirement was 1020 mm square, but by providing a 12 diameter 10 numbers, I'm getting 1131 mm square of the area, and the provided steel is okay. So according to the calculation, it is okay, but practically it is not possible to provide a 12 diameter 10 number of a bar in a single layer. So instead of this, what I'm supposed to do, I can make another layer here. I'll give 12 and I'll put 5 here and I'll put 5 here. Now you're getting my point. Now again, the area remains the same, but the way you have detailed now, so to practically, if I put this, so this should be something like this. I'll try to draw 5 there. Okay, see, this is first layer. How many bars I require? 5. 1, 2, 3, 4, 5. Similarly, in the second layer also, see, 1, 2, 3, 4, 5, right? So this is how you are supposed to do. Now again, practically this is not possible. We were not going to give so much reinforcement. So what we can do, the best idea is that instead of 12 diameter, go with the 20 diameter. So provide a 20 diameter 3 bar, and or you can provide a 25 diameter 3 bar. I'll make this as 0. Okay, I hope by this time you got an idea. This is all up to you. You can decide whatever you want. Say I require 1030 mm square of area to be satisfied. What I'm gonna do, I'll provide a 25 diameter 3 number of a bar. If I provide a 25 diameter 3 number of a bar, I'm giving 1473 mm square of a steel, but my requirement is only 1034. That means I'm giving more steel, which is not economical, right? So as a structural engineer, I want my structure to be safe and also economical. So instead of providing a 25 diameter 3 bar, you can make a combination now. So what I'm going to do, I'll make a 16 diameter 3 bar. Okay, that is in layer 1. Then again in layer 2, I'll go with a 12 diameter 2 bar. So we'll try to see whether this will work out. Okay, I'll go with a 12 diameter 3 bar. Yeah, even this is also insufficient, right? So I can go with another combination. We'll go with the 20 diameter 3 bar here. And in the second layer, I'll go with a 12 diameter 2. Yeah, now this is very good. See, my steel requirement was 1030. I'm going to provide a 20 diameter 3 bar in the layer 1. And I'm going to provide a 12 diameter 2 bar in the layer 2. So by providing this much area, by providing this much steel, I'm going to satisfy 1169 mm square of the area. Now you can take this as a kind of assignment and quickly tell me how you are going to detail this. I'll do it for you. You can do it on your own if you have understood the concept so far. Else you can listen to me. See, so this is layer 1. So this is my layer 1. 1, 2, and 3. Got it? So this is my 20 diameter 3 bar. And again, I have to provide a 12 diameter 2 bar, but it is in layer 2. I'll make use of a different color. Okay, this layer 2, I'll provide one bar here, I'll provide another bar here. You're getting the point? This is how you practically do it. Now you can write it here, that if you want to write, let me quickly do that. I'll do in this way. Yeah, I'll write here. So this is my 20 diameter 3, or okay, 20 diameter 3 bars. Okay, in the same way, this 2 bar also you can write. It's a 12 diameter 2 bar. I'll write it here. Okay, you have to write it properly in the AutoCAD. I'm showing it here. So this is a 12 diameter 2 number of bar. Got it? So this is how now it is understood to the contracting people. I mean, people those are working at the site, that you have to provide a 20 diameter 3 bar in the bottom and 12 diameter 2 bar at the top. Got it? So this is how you are supposed to do. Similarly, we'll come to this now. See here. Now come to the compression reinforcement. This already we are satisfied. It is all up to you to decide what diameter you can go. Okay, I have done this. You may even give a 25 diameter 3 bar and finish it off. No issues. Like for example, instead of this, I can make this as 20 diameter 4 bar and I can go. Even then also it is okay. See, then what would have happened? These layers won't come. This and this will not come. We'll remove all these things. Okay, you can do even this also. Even this is coming out to be safer, right? So what we can do is, I'll go with this. I'll provide a 20 diameter 4 bar. My requirement is 1030, but I'm providing 1257, almost 200 mm, 250 mm extra I'm providing. It is okay. No issues. It's all up to you. As a structure, we have to provide 4 bar. I'll go with 4 bar. 1, 2, 3, and 4. Got it? So this will be my 20 diameter 4 bar. It's all up to you to decide what exactly you want to do. Now we'll come to the compression side. So in the compression, you see what is the steel requirement? It is only 167 mm square of steel is required, which is very less. Okay, it is not exactly doubly reinforced. It is you can say it is just a doubly reinforced beam. Okay, because 167 mm square is a very small area. So if I provide a 10 diameter 2 bar also, it will satisfy. I'll go with the 10 diameter 2 bar. See, yeah, it won't satisfy. We'll go with 12 diameter 2 bar. It's okay, no issues. See, by providing a 12 diameter 2 bar, I'm getting a steel of 226 mm square. My requirement was only 167. Why I'm seeing here? Because I'm getting a compression steel and this is a compression reinforcement. So I have to check here. Only in one layer it is enough, right? So what I'm going to do practically, when I give the drawings, when I release the drawings, I'll put it in this way. This is my 12 diameter 1 bar. This is my 12 diameter another bar. Okay, so here it was 12 diameter 2 bar, and this is how you are going to do practically. Getting my point? So in this way you are supposed to do all these things. Okay, but again, this is not the exact way what we do. Of course, this is one way to do. In the next lecture, I'll show you with the help of ETABS software how all these values are getting. Here I've taken 150, isn't it? But this 150 you are going to take from the ETABS software. I'll be showing on a live project how these things are carried out. I hope up to here you are able to understand how all these things are done. So if you want to learn all these things in a more detailed way, there is a course of mine by name ETABS. Okay, learn building analysis and structural designing with AutoCAD. There I've explained you on a complete model how to do, how to understand all these things and how it has to be done. Here I'm giving you a basic idea so that at least at least by being a site engineer, you should know how all these values are coming. Yeah. Now coming to the shear reinforcement. So in the shear reinforcement, you can, yeah, for the shear it's not working. Okay, no issues. For the shear, I'll be taking up the shear part in the next lecture because it's not working in the, yeah. Okay, I'll come here. Yeah, the problem is that we'll give 4 and 5 here. Now it will work. Yeah, fine. Because you see, one more thing I want to address here. See, now I gave this HISD bar as 500, isn't it? So that is why I was getting error here. Now, according to IS 26.5.16 of IS 456 2000 code book, for the stirrup, no, we have to use a 415 Newton per mm square grade of a steel. So that is why, since we had given an input of 500, it is not showing me any value. So practically the code says that you cannot give a stirrup of a grade greater than 415 Newton per mm square. But like I mentioned, 4 and 5 Newton per mm square grade of a steel is practically not available on the site. So what we can do is we'll do a design for 4 and 5 only, no issues. But practically we are going to give a 500 only and no issues. We are trying to be more safe. Now you see, If now let us say the shear force. So let us say I'm getting a shear force of 500 kilonewton. So based on that, you can decide how many leg stirrup you require. Okay, I require a 2-leg stirrup, and the diameter, let us go with the 10 diameter. And coming to the spacing, I should get a spacing here. Yeah, yeah, the spacing is not working. Revise sectional dimensions. Okay. Okay, the provided state is insufficient. I will change it. Okay, let me go with the 25 diameter 4 bar, and also here I'll go with the 16 diameter 2 bar. It is insufficient. I'll go with 3 number. Okay, it's 4 number. Yeah. Yeah, I've given an input of 150 kilonewton shear force here. Okay, so by giving a 150 kilonewton shear force, you can see here I'm making use of a 2-leg stirrup, and the stirrup diameter I'll go with the 10 diameter. I can even use a 8 diameter, so we'll go with the 10 diameter only. Okay, you can get it. You are getting idea. You provide 134 center to center spacing. So what conclusion you can draw? If you had seen while we were discussing about the stirrup, we were writing, right, that we have to make use of a 2-leg stirrup at 150 center to center spacing. From where we were getting all these things? Again, practically it is written here. See, you have to make use of a 2-leg stirrup. Now you can change this into 4-legged also. Practically 4-legged and all, we don't try to give unless there is a need, and it is very difficult. 2-legged will go. We'll make use of a 10 diameter bar, and the spacing is 134. So instead of 134, we can make this as 125, because you see, whenever you give the spacing, you can have to keep in the range of either 100 center to center spacing. Next, you can go with 125, you can go with 150, you can go with 175, and you can go with 200. Never try to keep like odd numbers like 134, right? 134, 146. All this is practically not possible on the site. So that is why, even though it is telling 134, we'll try to reduce. You should never increase. Instead of 134, you cannot give 150. Come to the lower value. The next lower is which one? 125, right? 125 is close to 134. So for this particular thing, I'll write in this way. I'll write here. So I'm going to provide a 2-leg stirrup, 2-leg at, okay, 2-leg 8 dia, which is a diameter 10 diameter bar at, what is the spacing? 134 we have got. I'll give at 125 center to center spacing. Got my point? So this is how you are supposed to do it. So that is why whenever you, now you got an idea, now you are in a position to understand all these things. Now you got idea how this guy has got 2-legged 8 bar at 150 center to center spacing. He has done the same thing. Whatever we did, no, he has input the value, and based on that, he has got that value. In the same way, he has got a steel here. You have to provide a 16 diameter 3 bar at the top. You have to provide a 16 diameter 2 bar in the bottom, and then your curtailment bar. This is curtailment bar. That is in this curtailment bar is a second layer. Okay, like for example, the 16 diameter 3 bar, whatever he has written, no? So this is a second layer. If you come to the tension zone, in the tension, for example, okay, I hope you are able to understand. I'll go with 12 diameter 2. Okay, we'll go with 4. So this he has written 12 diameter 4. This is layer 2, 12 diameter 4 bar. Okay, so that is what he has written here. Okay, you can see 16 diameter 3 bar is in second layer. But only the thing is, it will be curtailment. You won't get all those things in the Excel sheet. Practically, this is what we follow. Instead of providing this bar completely, in this way, we'll try to curtail, and this is what we do the curtailment. Up to here only, my maximum bending moment, that is sagging bending moment, is up to this distance. So that is why I'll provide additional steel in this direction. Got it? You can do the curtailment there. Yeah. So I think most of the things I've explained you about how to design the beam and all. So practically, this is what we try to do. Hope you have got an idea how to give the tension steel, how to give the compression steel, how to design it all. So all this design requirement will depend from structural engineer to structural engineer, whatever is good for him, and based on his idea. And also we have to keep a site execution point of view. Okay, for example, I want to address one more point here. For example, let us consider, instead of this, I'm providing a 16 diameter 6 bar, and we'll make this as 0. and we'll make this as nil. Yeah, I'll go with the 20 diameter. Yeah, you see here what has happened. We'll go with the 5. Yeah, you see here. Okay, I'm providing a beam width of 230 mm and the depth is 300 mm, and I'm providing a 20 diameter 5 bar in a one single layer. Here the provided steel is okay. That means practically, according to the calculation, my steel is okay on my paper. But practically, you think whether it is possible or whether it is feasible to provide a. Now, what is the breadth of this? So it is 230 mm, and what is the depth of this? It is, we'll see what is the breadth of this. We have taken 300 mm. Okay, good. Now write it here. So this is 230 and this is 300, right? Yeah. Now just imagine, is it possible for you practically on the side in a width of 230 mm, can you accommodate 20 diameter fiber? Practically it is not possible. Why? Because 230 is the overall width of your beam. So you have to take out the cover from both the side, isn't it? You have to take out the cover from both the side. So I'll do it quickly now. I'll first write this because all these things you should be knowing. So that is why I'm explaining you. Yeah, quickly let me do that. See, 5 bars I'll try to accommodate 1, 2, 3, 4, 5. Got it? Yeah. Now try to see practically is it possible or not. So we'll try to do a calculation. So 230 is the overall width of that. Minus in the beam we are taking a 25 cover. You have to, because this bar you are going to leave a cover of 25 on this side and you are going to leave a cover of 25 on both the side. Only then you are going to keep the bar, right? Just remember the practical beam what we had placed in the first video what we had seen, right? He had done that adjustment of 25 mm. So then after that you see, then your stirrup is going to come. 8 mm stirrup is going to come from here 8 mm and from here also 8 mm minus 8 mm minus 8 mm, and then you tell how many 20 diameter bar are there. So 120, 2, 3, 4, 5. So minus 5 20 diameter bar, 5 into 20. So do this calculation and tell me what is the answer you're getting. I'll repeat it. 230 is the overall breadth, minus 25 cover on the left side, minus 25 cover on the right side, minus 8 mm stirrup on the left side, minus 8 mm stirrup on the right side, minus you do that how many bars are there? 20 diameter 5 bars are, so 20 into 5. So you are going to get an answer of how much? 64. So that means 64 is the overall spacing that is left. So this is only 64 what is left. So this 64 you divide it by the spacing. How many spacing you are going to get? See, in between this two bar I have one spacing, in between this two bar two spacing, in between this 3, in between this 4, that is one spacing, 2, 3, 4. So this 64 you divide by 4. 64, if I divide this by 4, this will give me the gap between the two bar. You're getting my point? That is what I'm interested in. So I'm getting only 16 mm. I'm getting only 16. And practically it's not possible to have a gap of 16 mm. The code says that whatever is the size of aggregate, 5 mm more to that, that should be the gap. That means the nominal size of aggregate what we use is 20 mm. So code says that 20 plus 5 is what you have to do. 20 is same for all the beams. Okay, you take 25. That means 25 mm should be the minimum gap between these two bar. 25 mm should be the, because why is that this gap has to be kept? Otherwise your concrete and the aggregate will not pass through this, right? If you keep it at a very close spacing, your concrete aggregate is not going to pass through that. So the code says that minimum you have to keep 25 mm, but according to our calculation we got 16 mm, and this 16 mm is less than 25 mm. So practically we cannot go with this arrangement. Got it? So that is why what we are supposed to do, even though we are getting a good steel here, practically it is not possible. So what we are going to do, we'll keep a 20 diameter 3 bar only. 3 bar is good. And now in the next layer you go with the 16 diameter 3 bar. Now is it okay, or you go with the 16 diameter 2 bar? Yeah, see, this is very good. You got it. Now practically it is possible. Yeah, let me take this. You take this as a kind of assignment and you can quickly do that. Tell me what is the spacing you're going to get. Okay, I will do it here. You also can do it along with me so that you get all these ideas. Yeah, so I'll draw out quickly 20 diameter 3 steel here. Okay, now quickly do the calculation and tell me. I'll do it directly. 230 was the width, minus 25 mm on the left side, minus 25 on the right side, minus 8 mm stirrup, minus 8 mm, minus what you have to do. This is how much? 20 diameter bar 1, 2, and 3. So 20, 20, 20 comes out. I'll write 20 diameter 1, 20 diameter 1, 20 diameter 1. Okay, do it. So 230 minus 25 minus 25 minus 8 minus 8 minus 25 minus 25 minus, sorry, minus 20 minus 20 and minus 20 minus 20 minus 20 and minus 20, because I'm using a 20 diameter bar of 3 number. So I'm getting 104. Hope you got a same answer. Now this 104 you have to divide by spacing. Okay, see, in between these two bar I have one spacing, in between these two bar I have another one spacing. That means I have only two spacing. So now you divide this 104, you divide it by 2. How much you'll get? It is 52, right? 52. Yeah, 52 is the spacing what I'm having, and according to the code book it has to be how much? 20 plus 5, that is 25 mm, and my 52 mm is greater. I'll write here my 52 mm what I have got is greater than 25, and practically it is okay. It's okay. It's okay. We can go ahead with this. So we have done all the things, and practically this is possible. So you can go with this combination. Okay, you can put a 20 diameter 3 bar in the bottom, and of course the 16 diameter 2 bar will come over this, which you already know. This is my 16 diameter 1 bar and 16 diameter another bar. Got it? Yeah, I hope you have gotten complete idea regarding how all these things has to be done. It's not as easy because we have done only for a single beam. Now just imagine being a structural engineer, to do all these beams detailing, it will take time. Okay, so you should be good in AutoCAD and all, only then you can do all these things. Because right now what I've done is only with the help of this Excel sheet I've explained and written with the help of a text. But practically when you release the drawings, you have to do all this with the help of AutoCAD. You have to write all these things, so you require a good knowledge about AutoCAD. A good draftsman can do all these things. Okay, yeah. So I hope I was able to convey most of the things to you, and I hope you have enjoyed the lecture up to here. In the next lecture, we'll be taking up the E-tabs, and we'll see practically how the bending moment looks in the E-tab. We'll see you back in the next lecture. Thank you.